Hey, we're back with looking at solving systems algebraically. Now, I'm going to go over a couple of different ways to solve with you algebraically. The first one we have today, we say it's using substitution or the substitution method. Okay, so we're going to do exactly what this talks about. We want to take our equations and substitute one in for the other. So let's talk about this a little bit. And I'll look down here at our equations. So when we're trying to solve, so think about when you solve a regular equation for a variable. You can only solve the equation with one missing number, one variable in it. We've never solved an equation with two different variables. So here, when we have a system, we have x's and y's. So we have to get rid of one of those variables in order to solve. So we're going to do what we call substitution. And it's exactly what it sounds like. So steps. Step one, we're going to substitute to make one equation with one variable. We're going to then solve for that variable. So now that we have an answer to a variable, we're going to go ahead and substitute again into one of the equations to find the value of the other variable. So we do have to, in the end, find both. Remember, when solving a system, we're finding a coordinate. And once we move away from graphing, we forget that our goal is to find an XY coordinate. Okay? So we're then going to check our work using the opposite equation. So this work can get a little long. Okay. So step one, I'm going to substitute to make one equation. So if I have y equals all of this, these two things are equal, and it's hard to kind of picture right now, but if all of this equaled 10, then, right, we'd say it equals 10. Y over here is 10. So this, once we know what x is and we plug that number in, we can get an answer that's our y. So these are equal in value. Well, if y equals all of this, no matter where y is, it is equal to 5x plus 1. So here I have a y. And notice I'm doing parentheses because I like to use these parentheses here. So if y is all of this, and here's my y in my other equation, I'm going to replace or substitute y with what it's equal to. So I like the parentheses because I'm going to take what's here and I'm going to smush it into there. So I'm going to rewrite 4x plus, this comes out, y is 5x plus 1, so y is 5x plus 1. So I'm replacing it. I'm substituting. This is step one. Equals 10. Okay. So that part can be a little tricky. Now I'm going to solve. Combine like terms. 4x plus 5x is 9x plus 1 equals 10. Subtract 1 from both sides. 10 minus 1 is 9. Divide by 9. X equals 1. So there is step 2. Right? We solved. Oh, can't see it. We solved for the variable step 2. Step 3. I'm going to substitute in my answer. So this is only half of the answer. Remember, our goal is to get a coordinate. So we have half of our answer. We found the x. So now I've got to do step 3. I'm going to substitute my answer into one of the equations to find the other variable. Doesn't matter which one. I mean, essentially, I guess I could do both. That would be a way of checking it as well. Make sure I get the same answer. So remember, our goal is that whatever we find here, we want those same exact numbers to work here. So whatever we find we found 1 for x, well, let's substitute that in. So step 3, I'm going to take my first one, y equals 5x plus 1. And now I'm going to substitute in 1 for x. So y is equal to 5 times 1 plus 1. 5 times 1 is 6. 5 times 1 is 5 plus 1 is 6. So y is equal to 6. So here I believe my answer is x comes first, 1 comma 6. So here's my answer, my solution. Okay. So these numbers, so I've got 1 and 6, they should work in this one in order for this to be the intersection point. Remember, if we were to graph this, it's where they cross. It's where they share the same point. So I'm going to check to make sure that I didn't do anything wrong. So I'm going to take 4x plus y equals 10. Now we had x equals 1 and y equals 6. 4 times 1. Oh, and 4 plus 6, right? Hopefully you could already see it here, is 10. 10 equals 10. I know I did that correctly. Okay, so that was step 4, my check. I can't forget to state my solution. The solution is an intersection point. Okay. I like these ones. So, y is equal to this. Y is also equal to all of this, so they're different. Well, y is all that. I'm going to replace it over here. I'm going to put that in for y. So essentially, if y is equal to this and y also equals that, this and that have to equal each other, right? Or in other words, we're going to substitute in over here. So 3x minus 2 is equal to 2x minus 5. Variables on both sides. I like to move the smaller one. We get 1x. Bring down everything else, so minus 2 equals negative 5. Add 2 to both sides. 1x is equal to negative 3. 1x is just x. Some of you guys like to show this divide by 1. X equals negative 3. Okay. Sorry, this was part 1, my substitution. Part 2, I just solved. Part 3, I now have to take this x back to one of our equations. I'm going to use the top one. And now I've got to find y. So 3 times negative 3 minus 2. 3 times negative 3 is negative 9 minus 2. I've got negative 11. My answer then, I believe, x comes first, right, then y. So negative 3, negative 11. Here's my solution. I'm going to check it. So I have to take the other equation, right? It wouldn't make sense to use this. So I'm going to make sure that it works in the opposite equation, the one I haven't checked yet. So negative 11 is what I found over here. So I want to find that again. 2 times negative 3 minus 5. 2 times 3. 2 times negative 3 is negative 6. Negative 6 minus 5 is negative 11. We did that correctly. I apologize. Step 4, my check. Okay. We're going to do more together. But as we do this, maybe pause your video if you're feeling like you're getting the hang of this. I know this is a little bit more difficult. Okay, 3. I have an x equals. That's okay. It doesn't matter which one we substitute. So same idea. All of this is going to replace the x, though, because it's x equals. Okay. So step 1, substitution. 3 is there. I'm going to use parentheses this time because I have 3 times x. So now I need 3 times everything x is. So I need 3 times all of this. Minus y equals 1. Distribute. 3 times 12 is 36. 3 times 2 . Okay. If you feel like I'm ever going too fast, pause the video, right? Catch up. Do some thinking about what's happening. All right, combine like terms. We got to be careful. We always talk about keep the sign with the number. -6 minus invisible 1 right here, 1. So -6 minus 1 is -7y. Also, have a calculator with you, especially if your integer skills aren't up to par here. Use your calculator. 2-step, I need to subtract 36 from both sides. I can't lose my negative on my 7. 1 minus 36 is a -35. Divide each side. I've got y equals +5. So that was step 2, I just solved. Step 3, I now need to put in my y value to solve to find x. So I got 12 minus 2 times 5. Multiplication first, so be careful there. 2 times 5 is 10. 12 minus 10 is 2. So careful when you put your coordinate together. X comes first. 2, 5. Here I believe is my solution. Of course I'm going to check it. I want to make sure that I'm doing my work correctly. So my check, I use the opposite equation. 3x minus y equals 1. 3 times 2 minus 5 equals 1. 3 times 2 is 6. 6 minus 5 is 1. I did it correctly. All right, if you're feeling confident, pause your video. Start trying 4. Solving for x again. Parentheses here, parentheses around my x. Ooh, boy, I got a negative out front. Remember, invisible 1, that might be helpful. Okay, -1 stays, or just your negative sign. All of this goes in, y minus 1 plus y equals -1. Distribute. -1y plus 1 plus y equals -1. Let me go over that. Negative times a positive, right, is our negative. We could even draw the 1 there. Negative, remember, times a negative. So we got the negative out front times the negative inside is a +1. That tends to screw us up. All right, combine like terms. I've got -1y and +1y. Well, -1 plus 1 is 0. 0y plus 1 equals -1. This is weird. Well, 0y's is just 0. So 0 plus 1 equals -1. Well, 0 plus 1 is just 1. 1 equals -1. Well, what the heck? our variables are gone. What does that mean? What did we do? Did we do something wrong? Obviously, I didn't do it wrong. Okay. Remember when we graphed? There was 3 options. We'd find the intersection point, right? It's a coordinate. What about those other 2 options? There was no solutions. Lines don't cross. Or lines are the same. And they're all solutions, infinitely many. Well, this tells us something. Is 1 equal to -1? Is that true? I hope you're saying no. It's not true. So if it's not true, there are no solutions. It doesn't matter what numbers we choose for x and y, we will never find a combination that works. This has no solutions. I'm going to go a little bit farther. Don't get upset with me. I know it makes our video a couple minutes longer, but I think it's important. I'm rewriting the equations. That's all I'm doing here, -x plus y. I'm going to solve these for y so that you can see y equals mx plus b, and we can compare them. You will not have to do this on any of the work I give you. Okay, this one's pretty easy. We want y alone, so I have to get rid of the -1. I do the inverse. I can't add x plus 1, so I'm just going to show x plus 1 equals y. Well, we like y over here, so y equals x plus 1. Okay, over here, y by itself, I need to get rid of the x, so I'm just going to add x over there, get rid of it over here. Y equals -1 plus x. I'm going to rewrite it this way. I'm going to do plus x minus 1, so x minus 1. So are they exactly the same? No. I hope you said no. But we talked about in our last video that m value. Here our m value is the same. It's 1. So they have the same slope, different y-intercepts. They will never cross on the coordinate plane. They will be parallel. Whenever our lines are parallel and there's no solution, your variables are going to disappear because the slope is the same. But your statement at the end here will not be true. No solutions, not true. Okay, let's keep going. 5. Y is all of this. I'm going to take all of that and I'm going to plug it in for y. Smush it on in. So step 1, 2x plus 2. I'm using parentheses because this is 2 times y. I need to distribute. 5 minus x equals 10. All right, step 2, I'm going to solve. Start with distributive property. 2x plus 10 minus positive 2, right, so it's positive, 2x equals 10. Combine like terms. Here we go again. 2 minus 2. 2 minus 2. I hope you all know the answer to 2 minus 2. 2 minus 2 is 0. They cancel. I'm left with positive 10 equals positive 10. What does that mean? I hope some of you guys can guess it. Well, remember, we just talked about it, the 2 options. 2 other options, I should say, right? It didn't have, we couldn't find an intersection point. But this time, our statement is true. This is true. What's our answer? Infinite solutions. Infinite solutions. They are the same line. Maybe not so easy to tell up here, but these two are the same line. I know I'm reaching 20 minutes, so I'm not going to solve for y in this one. Trust me on it. If I were to take this and solve this for y, I'm going to find that same exact thing. Same line. Infinite solutions. Well, look at this. We kind of got to skip some parts here. I didn't do this on the last one. There's really no check because there's nothing to check. All right. Final answer, infinite solutions. All right. I'm going to do one more with you. Problem 6, a word problem. And then you guys try 7 and 8. And I'll show you the answers. So not too much longer here. Okay. Suppose you have $55 in your bank account. You start saving $10 each week. Your friend has $20 in her bank account and is saving $15 each week. When will you and your friend have the same amount of money in your accounts? Okay, we have to make the equations ourselves. You have 55. It's already there. It's not going to change. We've got 55. You're going to then start adding 10 a week. So y equals 10 each week. So y is going to be money. And x, we just said 10 each week. X is weeks. Plus the 55 you have. Your friend is going to save 15 each week and has 20 in their account. So we've got our two equations. Let's do that substitution. All of this is y goes into here. This might make a little more sense too in the word problem. You want to know when you and your friend have the same amount. So how much money and how many weeks did it take you to get there? So you're just setting the two equal to each other. You want to know when they're the same, when they're equal. 10x plus 55 equals 15x plus 20. Variables on both sides. You know me, I like to move the smaller variable. 55 is equal to 5x, bring down plus 20. We've got our two-step, subtract 20 from both sides. Five minus 0, 5 minus 2, 35, divide by 5, x equals 7. So remember, 7, we wrote it over here, 7 is equal to x. X is weeks, that's 7 weeks. So when will you and your friend have the same amount of money? 7 weeks. So essentially, we just answered the question, 7 weeks. Oh, but guess what? We're going to see how much money you've saved at that point, and this is how we're going to check our work. We want to know if we did it right, we're both going to have the same amount. So $10 times 7 plus 55. We've got 70 plus 55. 125. So that's dollars. Well, let's see if your friend also has $125 in 7 weeks. So that is 15x plus 20 times 7 plus 20. 5 times 7 is 35. Bring the 3 up, 7 plus 3, so it's 105 plus 20, 125. We know we did it correctly, and what that just took us an extra minute or two, right? Maybe quicker even if you had a calculator. I don't have mine on me. So check your work. All right, pause your video. Try 7 and 8. I'm not going to work through them with you. I'm going to give you the answer. Okay? Pause your video. Here's 7. My solution is 4, 3. Got my substitution. Step 2, I solved to find y equals 3. 3, I plug in. I found x equals 4. Here's my answer. Here's my check. All right, and 8. Okay, same thing. Substitution. This one I didn't have a choice. I had to move the x over here, subtract it. They may have been a little tricky. Found x equals 1, plugged it in, found my y, found my solution, and I checked it. All right, guys, you're doing great. We're almost there. Summer vacation's around the corner. All right, hang in there with me through this unit. Please come to office hours. This one is a bit, this might be a bit more challenging. Come to office hours. Even if it's a nice sunny day, it's only a half an hour out of your day. All right, we'll see you later.